Timber column design. Typical cross section of timber is like this, and you can also have a square section. It is actually advantageous to use a square section for columns because it's gonna buckle towards the weakest direction. So even though you are using this material, so it's gonna buckle this direction. So if we draw a column like this, like that, and then if we add some load here, because it's weaker this direction, it's gonna buckle this way. So it doesn't really add mass when you use a rectangular section. Instead of that, if we use a cross square section, it actually most useful. Anyway, so the way the calculation is done, so you calculate the slender ratio. It should be less than 50. For a steel column it was less than 200, but for timber it should be slenderness ratio should be less than 50. And for the steel columns we have divided by the radius of gyration. Here on the other hand, we're gonna divide by d. D is the shortest side. So for example, this d value would be this side, not this side. So that's d, and then L is a length, and then K is depends on how the column is attached to the end. If it's free connection, then K value 1. If it's hold both sides like this and hold here, then it's going to be 0.5. We can look at the table to calculate K. So that's the slenderness ratio. Once you calculate that, it should be less than 50, and then you start working on it. So this is how the compressive load is calculated for columns. Now FC is the allowable compression for a particular timber, maybe a Douglas fir or redwood. All of these has its own capability. The property can be found in the appendix, and then we can put that. However, the calculation we need to do is for this constant CP. The constant CP comes from these equations, and then you have this alpha comes from these equations. First you're going to calculate this, and then that would be your step number 2, that would be your step number 3. Well, before that you need to calculate this step 0, I would say, to check whether it's violating the slenderness ratio. If it's too tall, you can't really calculate anything. It probably will buckle even without any load.